Today we have a trigonometry problem. We were given that sine of theta equals minus 5/9, where theta is in quadrant 3, or sometimes we say angle theta terminates in quadrant 3 or whichever quadrant. Find the remaining 6 trigonometric ratios, or 6 trigonometric functions, sometimes we say. All right, so the first thing I want to do is kind of recall what we mean by those ratios. So I'm going to have us look at what we have here. Let me just zoom out just a bit. So we have given theta, an angle theta terminating in a quadrant and measured from a standard position, and basically this means like the positive x-axis here. Then we have the following definition. So I drew an angle here in the first quadrant, but this applies anywhere. And you have this value r, which is the distance from the origin to that point xy. And for that angle, there's a unique value x and y. Now, the 6 trigonometric ratios are, as you can see here, are the following. You have sine theta is y over r, cosecant is r over y. Notice how cosecant is a reciprocal of sine and vice versa. Cosine is x over r, secant is r over x. Tangent is y over x, and cotangent is x over y, with r being the square root of x squared plus y squared. Okay, so we're going to be using that here. Now, the first thing we're going to do is we're going to, first of all, draw the angle in so many ways. I don't need to actually know what the measurement of the angle is. All I need to know is in quadrant 3, so we drew that. And right, we need to know the quadrant of that angle. If I don't know the quadrant of that angle, then really you can't really solve these problems. And I have that the sine of this angle is minus 5/9. So as you recall, we wrote that the sine of theta is equal to y over r. Now what this means is, it doesn't mean that y here is minus 5 and r is 9. It means that the ratio, whatever the y value is, over r is minus 5/9. However, you can go ahead and assume that y and r are actually equal to minus 5 and 9 respectively. And essentially that's what we do for the most part with these problems. If you're given something like sine is, this number over this number, we assume that y is equal to minus 5 and r equals 9. Okay, so I'm going to somewhat draw that here. Y is its vertical distance, that would be like minus 5, and r is that distance from the origin to the end where that angle terminates. And what I need here is this value x, which is this distance. Okay, and how do I find that? Well, you have the Pythagorean theorem that you can always use, and that's always the case. When you draw this triangle, you can always use the Pythagorean theorem. And by the Pythagorean theorem, let's call this x right here. You would have x squared plus minus 5 squared equals 9 squared. 81, 25. So x squared plus 25 equals 81. So x squared equals 81 minus 25. So x would equal, let's see, it looks like it would be 56 if I'm not mistaken here. 5, yes, okay. So then what we're going to do is we're going to go ahead and take the square root of 56. Sorry, x squared is 56. X equals the square root of 56. My apologies on that. But we're going to take into account that this point xy, this value of x is in the third quadrant, so x is negative there. So this would be negative square root of 56. Again, because you're looking at the third quadrant, and the second and the third quadrant, x is negative. Now that you know all your values here, you can find the rest of the trigonometric ratios. Cosecant is just y over r, it's just a reciprocal, so I'm going to start with that one, which would be minus 9/5. Cosine would equal x over r, so it's minus root 56 over 9. Secant is the reciprocal, that's r over y, that'd be minus 9 over root 56. Tangent is equal to y over x. So that would be negative 5 over negative square root of 56, which becomes 5 over root 56. And finally, cotangent is equal to x over y. So this would be minus root 56 over minus 5, or if you prefer, it's root 56 over 5. It's the equivalent. And yeah, it's just a reciprocal of tangent. Okay, so we found all 6 of these ratios. So again, what you want to do here, first of all, is given the angle in the quadrant, you want to draw that angle. Okay, you're always starting from the standard position from the positive x-axis. You would draw it, and then you draw the values that are given. So in this case, we had y and r involved because sine is y over r, so we drew what y could be and what r could be. And from there, we filled in that gap to find x. And then from there on, you can find the rest of the ratios, okay, from that. And real quick, I just wanted to go what if you drew the triangles in other quadrants, what they look like. So in quadrant 1, yeah, if you have an angle in quadrant 1, your angle is just going to look like this. That's r, this is y, this is x. If it's in quadrant 2, your triangle would look like this, r, x, and y. So that's quadrant 2, and then finally in quadrant 4, you would have r, y, and x. Okay. So that's how you would draw them in each quadrant. Okay, so this is, yeah, I think from here on out it's pretty straightforward. Just work with those numbers and get your values. All right, well, thank you so much for your time, and I hope this helps.